Welcome back. In this video, we are going to find out inverse of the matrix by using adjoint method, where matrix A equals to 1, 2, 1, minus 1, 3, 0, 0, 2, minus 1. It is having 3 rows and 3 columns. Number of columns equals to number of rows, or rows equals to column. Rows equals to column. Therefore, it is a square matrix where the first row is denoted by R1, second row denoted by R2, third row denoted by R3, and the first column denoted by C1, second column denoted by C2, and the third column denoted by C3. So it is having 3 rows and 3 columns. Therefore, it is a square matrix. Whenever the number of rows and columns are equal, then we say it is a square matrix. Whenever you want to find out the inverse of the matrix by adjoint method, the step number 1 to find the determinant of the matrix. So determinant of A, how to find? Don't worry, I am going to give you the brief idea how to find out determinant of matrix. But the question is, why to find determinant of matrix? There are the one reason. If determinant of matrix is not equal to 0, implies A inverse exists. If determinant of A equals to 0, implies inverse of the matrix does not exist. Therefore, prior to starting the solution, first of all find out the determinant and be sure that the determinant of the matrix is not equal to 0. Then only you can proceed, otherwise you have to stop there itself. And second reason to find out determinant is A inverse equals to 1 upon determinant A multiplied by adjoint A. So there are the two reasons to find out determinant of the matrix. The first reason to test whether inverse of the matrix exists or not, and the second reason it is used in the formula of A inverse, that is A inverse equals to 1 upon determinant of A multiplied by adjoint A. So these are the two reasons to find out determinant of the given matrix before start proceeding. Now first of all, let us find out determinant. For that, write down the first 3 numbers of R1 as it is 1, 2 and 1, and change the symbol of the middle one, that is 2. 2 is the middle one, so change its symbol. If it is positive, make it negative. If it is negative, make it positive. So it is already positive, so make it negative. So middle number will make negative, and write down the determinant 3 times like this. Then here is a plus, here already minus. After that, you first delete column 1 and first row. What do you see? 3, 0, 2, minus 1. So write them here. After that, you delete column 2 and row 1. What are the elements left? Write down here. That is minus 1, 0, 0, minus 1. Now in the third case, you delete the column 3 and row 1. What are the elements left? Minus 1, 3, 0, 2. Now we apply the formula of second order determinant. That is, suppose A, B, C, D is the second order determinant. So second order determinant is equals to AD minus BC. So this formula will now apply everywhere. So 1 multiplied by minus 3, minus 0, 2 into 0 is 0, minus 2, minus into minus plus, plus 1, minus 0, and 1 multiplied by minus 2, minus 0. So that equals to minus 3 and minus 2 and minus 2 is equals to minus 7. Since determinant of A not equal to 0 implies A inverse exists. Now we'll find out the cofactor matrix of A. That is, we have to find out matrix of cofactors. We have to find out the cofactors A11, then A12, A13, then A21, A22, A23, A31, A32, and A33. How to find out these cofactors? To find out the cofactor A11, again the same idea. Delete the row in which the A11 is present and delete the column. What do you see? 3, 0, 2, minus 1. Now suppose you want to find out the cofactor A22. Then what do? You delete, this is the A22. So delete that row and that column in which A22 lies. Then what are the number left? 1, 1, 0, minus 1. And suppose you want to find out the value of cofactor A31. This is the element A31. So forget the row in which A31 lies and column. What are the number left? 2, 1, 3, 0. Similarly, we find out other cofactors. After that, write here plus, here is a minus, here is a plus, here is a minus, here is a plus, minus, plus, minus, and plus. Start with the plus, then alternatively we write down plus and minus. We start with plus, end with plus. That is important. After that, we'll find out second order determinant everywhere. So that is plus, minus 3, minus 0 equals to minus 3. Then minus 1 minus 0 equals to minus 1. Then A13 equals to plus minus 2 minus 0 equals to minus 2. Then A21 equals to minus 2 minus 2, that is equals to plus 4. Then A22 equals to plus minus 1 minus 0 equals to minus 1. A23 equals to minus of 2 minus 0 equals to minus 2. A31 equals to plus of 0 minus 3 equals to minus 3. A32 equals to minus 0 plus 1 equals to minus 1. And A33 equals to plus 5. Therefore, matrix of cofactor equals to minus 3, minus 1, minus 2, 4, minus 1, minus 2, minus 3, minus 1, and 5. Therefore, we got cofactor matrix equals to minus 3, minus 1, minus 2, 4, minus 1, minus 2, minus 3, minus 1, and 5. After that, to find out adjoint of this matrix, you find out transpose of the matrix. So that is minus 3, minus 1, minus 2, 4, minus 1, minus 2, minus 3, minus 1, and 5. After that, inverse of the matrix is given by A inverse equals to 1 upon determinant. Determinant is nothing but minus 7, and adjoint of the matrix, that is minus 3, 4, minus 3, minus 1, minus 1, minus 1, minus 2, minus 2, and 5. This is required inverse of the matrix by adjoint method. I hope after going through the steps, after going through this video, now you got a confident how to find out inverse of the matrix by adjoint method. If you feel you are benefited by this video, then I would like to request you, please like, share and subscribe the channel. Meet you again with another topic. Till then, wish you good luck, all the best.